It's not red. Sorry. Okay, I'm just going to ignore for a second this is secant, and I'm just going to go to its friend, which is cos. Okay. I'll come back to secant in a second, but let's just talk about cos. We did this yesterday. This is nothing new. First thing we do is think of the family. 60 degrees, what family? Pi on 3. Then we do coordinates. What's the coordinate of the pi on 3 family? 1/2 root 3 on 2. Then we decide if we want x or we want y. And how do we know if we want x or we want y? X is cos and y is, so we want the x value. Then we do the quadrant. We look at the numerator, which in this case it's just pi on 3, so it is quadrant. Oh. No. If that's someone in this room, I will hurt you. I probably shouldn't have recorded that. Like the minute I turn away, it's going to pop up. Okay, pi on 3 quadrant. And what do we know about cos in quadrant 1? Okay, so we know all of this equals 1/2. Again, all this stuff over here is just brain process. All you need to have is your 1/2. Now I'm just going to link it to secant. What's the relationship between cos and secant? They are reciprocal, so I'm going to take my 1/2 and flip it. 2. That's it. That's all we do with the reciprocal functions. We just take their partner and flip them. Cotan 120, scary, scary. Degrees in here, cotan in here. I'm going to ignore cotan for a second. I'm going to link to its partner. What's cotan's partner? Tan. If you can think in degrees, think in degrees. I link to radians. So if you don't know automatically what these radians are, you can always convert. So if you need to convert, it's just that 120 over 180 times pi. And I can cancel the zeros. And what can I do with 12 and 18? Divide by 6, which gives me 2 pi on 3. So it's the pi on 3 family. So the tan value of the pi on 3 family, that's a straight up memorization, or take the coordinates and divide them. Tan of pi on 3. The quadrant comes from the numerator. 2 pi on 3 is quadrant. What do you know about tan in quadrant 2? Okay. Again, this stuff off to the right is just our thinking process. If you need to write it, write it. Ian. So we memorize the 5 or 7 values of tan on the bottom. And so pi on 3, it's always tan is root 3. And that comes from the y divided by the x. Now I just need to go to cotan. What's under the negative root 3 that we don't see, but we know that it's there? And so when I flip it, we get?
Negative root 3 on 3.
If you want to rationalize, if you don't want to rationalize, leave it there. Does it matter where I put that negative? No, it can be on the top, can be on the bottom, come out to front. If you want to rationalize, you would get negative root 3 on 3. Cosecant 5 pi on 6. Again, just ignore the reciprocal function linked to its partner. What's cosecant's partner? I'll give you 30 seconds to figure out what the sine of 5 pi on 6 is. Check with someone sitting around you if you have the same value for sine 5 pi and 6. A little high five there. Yay. It sounds confirmed at positive 1/2. So how do we go from there up back to the cosecant? Flip it, which is 2. Turn and talk, do D together. This negative does not scare us. No, it does not. What is the negative? It's just a direction. And in telling us the direction, really what they're telling us is the quadrant. If positive pi on 6 is in quadrant 1, negative pi on 6 is in quadrant 4. It's just telling you quadrant reference. So what is the sign of just the pi on 6 family? I heard kind of a little mumbly 1/2. Because it's in quadrant 4? Negative. Final answer, negative 1/2. Why aren't I flipping it? It didn't ask for cosecant, it just asked for sine. Thumb so far, getting this, kind of getting this, not getting this. Put it really high so I can see. Okay. Oop. WTH, what the heck is that 3? Well, I don't know, so let's just ignore it for now, and that's a really good strategy in math. When you don't know something, do what you do know first. And we can do cotan of 7 pi on 3. I'm going to link to its partner. Cotan links to tan. I've memorized the 7 values of tan, so I know the tan of pi on 4 is 1. Now I have to figure out the quadrant. Look at the numerator. 7 on 4 is Q4. Tan in Q4 is negative. Yes, you're just ahead of me right now. Are we okay where that came from? So therefore, I can get the cotan of 7 pi on 4. How do I go from tan to cotan? Flip it, and what's the beauty of negative 1? It's the same. It's its own reciprocal. So I did all of this part. What do you think the 3 means in front? It's just multiply. It's just asking you for 3 times minus 1. This is a coefficient, which is what you learned in polynomials. It's just a coefficient. So it just means in the last step we multiply. What is 3 times negative 1? Negative 3. Do you want to go get me more? F. Bunch of stuff going on in F. We could just skip it. It's not a great move, though. We can't just skip plays in sports that we don't like. Well, we can, but then we wouldn't win the game, which means we wouldn't win the championship, which means we wouldn't graduate, which means we wouldn't be able to go to post-secondary education, get a job. We'd have to live in a box. And I love you too much to let you live in a box. Shaz, you're going to take that earphone out, though, right? Okay, what do you want to do? What does your brain say to do when you look at something like this? Do it separately. Because there's that plus, let's just do it separately. Now, if you're visual and questions like this scare you on the exam, use something to cover up half. Because sometimes that's less scary to your brain than having to look at the whole thing. If looking at the whole thing doesn't bother you, don't worry about it. But let's just do cos of 3 pi on 4. Figure out that value and write it down. Cos 3 pi on 4. When you think you got it, just compare with someone sitting around you. High five them, fist bump them. One high five. How about some more high fives? Yes. was actually a nice, like, backwards, like, high five there. That took skill. Offer? I heard negative root 2 on 2. Okay, so let me just go through the thought process. You go through the pi on 4 family, root 2 on 2, root 2 on 2. Cos is the x value, root 2 on 2. 3 pi on 4 is quadrant 2. Cos is negative, negative root 2 on 2. Okay, now let's just look at the other half. Okay, so ignore what you did on the left. Now let's do the right. Write down the value of tan 5 pi on 6. Over here I heard negative root 3 on 3. Thank you, Andrew. Can we confirm that? Okay, just again going through the thought process. Pi on 6 family, the tan is root 3 on 3. 5 pi on 6 is quadrant 2. Quadrant 2, tan is negative. Now I'm going to put those two together. This is just a subtraction of fractions. Who does not like fractions? Let's be honest here. Yeah, sometimes I don't like them either. If you don't like fractions, you're going to do a lot of swearing in Unit 2. So don't think you can avoid them in this unit because they don't come up often. They are like all in Unit 2, and you will cry if you do not learn how to add fractions. How do we add and subtract fractions? Common denominator, 2 and 3, 6. So this one's going to be over 6, and this one's going to be over 6. Then in our brain we say, how did I go from 2 to 6? What did I multiply 2 by to get 6? 3. And how do I multiply a root by a 3? Well, it just becomes 3 root 2. So we just take the whole number and the radical and slap them together. On the other side, how did I go from 3 to 6? Okay, so 2 times root 3 is 2 root 3. Just slap them together. What do we do once we have common denominator? Keep the bottom, and we just smush the top together. It's a very technical math term, smush. I'm going to use it a lot. It means just write all the top together. So minus 3 root 2, minus 2 root 3. That's the end of the question. We can't combine a root 2 with a root 3. Those are completely different radicals. G. Tan 5 pi on 6 we just did in the last question. What's tan of 5 pi on 6? Why is it negative? Quadrant 2. Okay, now I got to deal with cotan. I got to deal with this negative. I'm going to ignore cotan first. I'm just going to link it to tan. What's tan of 5 pi on 6? Root 3 on 3. What does the negative in front of the 5 pi on 6 mean? It's a direction. So if we were to go positive, we know it's in Q2. There's positive 5 pi on 6. So we've got a full quadrant. Oh, you can't see that. A full quadrant and a bit. If we go backwards, we're going to go approximately the same amount. So there is negative 5 pi on 6. It's only telling you a quadrant reference. What quadrant are we now in? Q3. So we know the tan of negative 5 pi on 6 is positive root 3 on 3. How do we go to the cotan? We flip it. So root 3 on 3, flip it over. Let's just repeat that. Why is it positive? Because we're going backwards. Negative 5 pi and 6 ends in quadrant 3, and tan is positive in quadrant 3. You want to do this the easy way, or you want to do this the hard way?
Easy.
Thought you might pick that. Let's rationalize. Even though you don't need to on the exam, it's a really good idea to do so here. Why? Because we're going to end up getting common denominator. If you don't want to, you could do a common denominator of 3 root 3. It's just going to take you more work. So I'm just going to rationalize this guy. So I'm going to multiply by root 3 on root 3. I'm not touching that first fraction. He's staying exactly the way he is. And so 3 times root 3, 3 root 3. On the bottom, root 3 times itself. Again, you don't need to do it this way. You could go through with your common denominator of 3 root 3. You're just going to end up doing more work. I'm just showing you the short way.
No, this is a couple thousand times easier.
It is, unless you don't like rationalizing. Some people find that hard, so for them it's harder. Now that I have common denominator, I'm going to keep that on the bottom, and I'm going to smush the top.
Well, if it's just a single term, rationalizing is easy.
To you, not to everybody though. Here I've got negative root 3 and positive 3 root 3. That's the same as negative x plus 3x. So negative 3 plus 3x is 2x. So negative root 3 and 3 root 3, 2 root 3. There's your final answer. Pick a couple questions on either joke 32 or 34, sorry, activity 22. Try some.